November 1951. Captain Dennis Campbell stands at a graveside watching them lower Lieutenant Michael Lithgow into the ground. 23 years old. Perfect approach, perfect speed. He'd floated just 6 feet too far and missed the wires. The barricade failed. His aircraft disintegrated in seconds. His widow, 5 months pregnant, stands beside Campbell. And something breaks inside him. This wasn't combat. This wasn't enemy fire. This was murder by equipment. A pilot did everything right and still died because 60 feet wasn't enough margin for error. What Campbell doesn't know yet is that his obsession with this death will save more lives than any weapon system ever invented. But first, he'll have to convince a room full of experts that a bureaucrat with a pencil sketch knows more than they do about carrier aviation. The numbers told a horror story. In 1951 alone, the U.S. Navy recorded 776 Class A mishaps, accidents resulting in death or total aircraft loss. More than 2 per day during peacetime. The Royal Navy wasn't much better. 43 aircraft destroyed in 12 months, 17 pilots killed. Every single loss happened in the final 30 seconds of flight. USS Boxer reported 7 barrier crashes in one deployment. Princeton lost 9 aircraft in 4 weeks. The jet age had arrived, and it was slaughtering naval aviators. Here's why. A Panther jet landed 40 knots faster than the old Hellcat propeller fighters. When you're traveling at 125 knots, you're covering 211 feet per second. On a straight deck carrier, for arresting wires stretched across 60 feet of deck. If you missed all 4, you had exactly 2.1 seconds before slamming into the steel barricade at full power. The barricade worked sometimes. When it failed, 30 tons of jet fuel and explosives plowed into the parked aircraft ahead, creating fireballs that killed a dozen men in seconds. Captain Bruce Williams watched 11 sailors burn to death in March 1951 when a barrier failed on USS Kearsarge. The accident report was clinical. Aircraft struck barrier at full power. Barrier separated. Aircraft continued into 6 parked Corsairs. Fire reached aviation fuel stores. 14 aircraft destroyed, 11 dead, 23 injured. Carrier operations suspended 48 hours. Williams would wake up screaming about it for years. The real nightmare was the psychological trap. Jet engines took 7 seconds to spool up from idle. An eternity when you're sinking toward the ocean at 20 feet per second. Pilots had to land with engines spooled up, power on, committed to the deck because they couldn't climb quickly if they needed to abort. Every approach meant staring at that steel barricade 60 feet ahead, knowing that if you floated even slightly long, you were about to die in fire and twisted metal. Everyone knew the problem. The British tried the flex deck, a rubberized landing surface that could theoretically catch jets without landing gear. Test pilot Eric Brown made 40 landings on it and called it fundamentally sound in reports. To his friends, he called it bloody terrifying. The Americans spent $3.2 million developing the Davis barrier system, stronger mechanical webs that could stop a 25,000-pound aircraft at full throttle. When it worked, it was impressive. When it failed, the devastation was total. But stronger barriers didn't prevent crashes. They just contained them. Captain William Rasher wrote in June 1945 that current landing procedures forced all aircraft into a 60-foot impact zone with zero margin for error, incompatible with jet aircraft performance. Translation? They were trying to land 1952 aircraft on 1942 ships, and people were dying because nobody could figure out how to fix it. Dennis Campbell wasn't supposed to solve anything. Born in 1907, he joined the Royal Navy in 1925, qualified as a pilot in 1931. During the war, he flew Swordfish torpedo bombers, earned the Distinguished Service Cross. Nobody called him a genius. After the war, they stuck him behind a desk at the Ministry of Supply as Deputy Chief Representative. His job was paperwork, tracking development schedules, attending meetings, signing requisitions. He had 0 engineering credentials, no advanced degrees. But Dennis Campbell had one quality that credentials can't teach. He couldn't ignore dead pilots. After Lithgow's funeral, Campbell told his deputy Nick Goodhart that they were murdering pilots with their own equipment. Goodhart expected nothing more. Officers always said things like that at funerals. But Campbell kept obsessing. He pulled accident reports, interviewed landing signal officers, studied crash patterns. He wasn't an engineer, so he did what non-engineers do. He drew pictures. The revelation came during a train ride from Portsmouth to London. Campbell sketched carrier decks in his notebook, trying to visualize how to give pilots more room. If you can't make the landing area longer, make it wider. If you can't make it wider because the ship has a fixed beam, angle it. He drew a flight deck canted 10 degrees to port. Now the landing zone didn't end at the barricade. It ended in open water. A pilot who missed the wires could shove his throttle forward, climb away, and try again. No barricade, no parked aircraft, no catastrophic collision. Just air and ocean and a second chance. The idea felt so simple it had to be stupid. Either he'd discovered something brilliant, or he'd overlooked something obvious that every real engineer already knew. August 7, 1951. Campbell convened a meeting at the Ministry of Supply. In attendance, Louis Boddington from Farnborough, Rear Admiral Slattery, 6 senior aviation engineers. Campbell opened his briefcase and showed them his sketch. The room erupted like he'd suggested flying carriers upside down. Commander James, senior flight operations specialist, didn't raise his voice. He didn't need to. That is completely illegal. The International Air Navigation Convention requires all flight operations to align with vessel axis. What you're proposing violates maritime aviation law written after 15 years of carrier operations. This isn't innovation, Captain. It's amateur nonsense. Campbell had expected resistance. He hadn't expected condescension. James continued, explaining that pilots would be landing across the ship's natural motion, fighting drift constantly, the deck moving underneath them in ways they couldn't anticipate. You'll increase crashes, not reduce them. Then Louis Boddington, the civilian engineer, held up his hand. Show me the math. James blinked. Boddington repeated himself. You say pilots will fight drift. Calculate it. An 8-degree angle on a deck moving through 12-degree rolls. What's the differential drift over a 30-second approach? Silence. Nobody spoke. Boddington looked around. Anyone? Then we test it. Boddington turned to Campbell. The Royal Aircraft Establishment at Farnborough has painted outline runways. We can paint an angled deck outline on HMS Triumph's flight deck. 1 week, simulated touch-and-go approaches. If the drift problem is real, we'll measure it. If it's theoretical catastrophizing, we'll know that too. Rear Admiral Slattery leaned back. Louis, you understand that if you paint an angled deck on Triumph and pilots start crashing, you're ending both your career and Captain Campbell's. Boddington smiled. Noted, sir. And if it works? Then we stop killing pilots who did everything right. September 1951. HMS Triumph left Portsmouth with an angled deck painted in white outline across her flight deck. Not structural, just paint. For 3 weeks, Navy pilots made touch-and-go approaches, pretending the painted line was real. The drift problem everyone predicted didn't exist. Pilots adapted in 2 landings. What they discovered instead was freedom. Lieutenant Peter Chilton later wrote about coming in too high, floating past the wires, and for the first time in his career, not being terrified. He just poured on power and climbed away. No barrier waiting to kill him, no aircraft ahead, just clean air and a second chance. He felt like he'd been given his life back. By October, the painted deck trials proved the concept worked. Now came the hard part. The carrier with the biggest problem, the one whose pilots were dying at twice the Royal Navy's rate, was American. And the U.S. Navy didn't take kindly to British officers telling them how to land planes. September 14, 1951. U.S. Naval Air Test Center, Patuxent River, Maryland. Lieutenant Commander Eric Brown stands before 40 American test pilots and feels every eye calculating whether to trust him. Brown is the Royal Navy's chief test pilot, the man who's landed more aircraft types than anyone in history. Right now, none of that matters because he's about to tell the U.S. Navy their carriers are designed wrong. Gentlemen, in the past 12 months, how many of you have hit the barricade? 7 hands go up, then 12, then 15. How many know someone who died hitting the barricade? Every hand goes up. Brown opens his briefcase. I'm going to show you something the Royal Navy is testing. It's going to sound insane, but I've made 63 landings on it, and I'm standing here instead of being scraped off a deck. He pins Campbell's diagram to the wall. An aircraft carrier flight deck angled 8 degrees to port. The room explodes. You want us to land sideways? The LSO can't see the approach angle. What about the island? You've moved the landing zone toward the superstructure. Brown waits for the noise to subside. Every objection you just shouted, We had every single one. Then we tested it. When you miss the wires on an angled deck, you don't die. You throttle up and go around. Simple as that. Commander Harold Buell stands up. Commander Brown, I've been landing on carriers since 1943. What you're describing violates every principle we've developed through 8 years of combat operations. You're asking us to throw away proven doctrine for a British theory. Brown's response cuts through the room. I'm asking you to stop dying for a design flaw. You're landing jets on straight decks because that's what you have. But straight decks were designed for Corsairs and Hellcats that could cut throttle and fall onto the deck. Jets can't do that. So you're forcing 1952 aircraft into 1942 operations, and your people are dying because of it. The angled deck doesn't violate doctrine. It adapts the carrier to match the aircraft. Rear Admiral Apollo Soucek steps forward. I've observed the Triumph tests. Commander Brown is correct. The concept works. I've recommended to CNO that we run parallel tests on USS Midway. But Rear Admiral Alfred Pride shakes his head. We're already testing solutions. The Davis barrier has a 98.7% success rate. Brown interrupts. 98.7% of what? Of the aircraft that hit it? What about the pilots who never reach the barrier because they see it coming in panic? What about the ones who deliberately ditch in the ocean rather than risk hitting the barricade at full power? Your statistic measures barrier performance. It doesn't measure pilot survival. Half the pilots are nodding. The other half look ready to throw Brown off the base. Admiral Soucek raises his voice. Gentlemen, silence. We will test the angled deck on USS Midway. Paint trials, simulated landings. If it works, we modify one carrier for full structural implementation. If it fails, we bury the idea. Admiral Pride stands for 10 seconds saying nothing. Then, Midway trials authorized. But if this British pipe dream causes a single additional casualty, I'm terminating the program and everyone associated with it. Brown packs his briefcase knowing he's just bet his career on a painted line. What he doesn't know is that within 90 days, the painted line will work so well that the U.S. Navy will convert USS Antietam into the first true angled deck carrier in the world. January 12, 1953. Off the coast of Guantanamo Bay, Cuba. Lieutenant Commander Harold Buell, the same officer who challenged Brown at Patuxent River, pulls his Panther into the landing pattern behind USS Antietam. This is his 43rd carrier landing, but his first on an angled deck that's not painted. It's real. An 8-degree sponson extending from the port side, structurally welded to the carrier's hull. Buell doesn't trust it. He's trained his entire career to hit the wires or face the barricade. That fear has saved his life twice. Now they're telling him to forget it. He drops his landing gear, adjusts trim, calls the ball. The LSO responds. Buell's approach is perfect until it isn't. A wind gust lifts his aircraft 6 feet. He's high, on a straight deck. This is where the LSO would wave him off and Buell would have to climb away, burn fuel, try again. But today, the LSO says nothing. Because on an angled deck, being high isn't a catastrophe. It's a correction opportunity. Buell drops his nose slightly, bleeds off altitude, but now he's long. He's going to miss the wires. On a straight deck, this is where panic sets in, where pilots make desperate corrections that cause crashes. But Buell forces himself to follow the briefing. If you miss, you climb. The deck is clear. Trust it. His wheels slam down. He bounces once. His tail hook skips over the 1 wire, the 2 wire, the 3 wire, the 4 wire. He's missed them all. On a straight deck, the barricade would already be tearing his aircraft apart. But there's no barricade. Just open deck and clear air. Buell shoves his throttle to full power. His engine spools up in 6 seconds. An eternity that feels like a gift. The Panther lifts. He's flying again. 23 seconds later, he's back in the pattern. Second approach, he catches the 3 wire. Perfect landing. Buell climbs out of his cockpit shaking. Not from fear. From relief he didn't know he'd been carrying for years. He'll later write that landing a jet on an angled deck was sheer bliss. For the first time in his career, he wasn't afraid of dying during every approach. The psychological weight that lifted off him that day, he didn't realize he'd been carrying it until it was gone. Over the next 60 days, Carrier Air Group 8 makes 1,327 landings on Antietam's angled deck. They record 8 bolters, missed wires requiring go-arounds. On a straight deck, 8 bolters might have meant 5 barrier crashes, 2 aircraft destroyed, 1 or 2 pilots killed. On the angled deck, 0 crashes, 0 destroyed aircraft, 0 injuries. The data becomes undeniable. Before angled decks, 1950 to 1952, U.S. Navy carrier aviation averaged 647 Class A mishaps per year. Landing accidents accounted for 52% of all losses. After angled deck implementation, 1955 to 1957, Class A mishaps dropped to 321 per year. Landing accidents accounted for just 19% of losses. That's a 75% reduction in landing accidents, 80% fewer barrier-related fatalities. But statistics don't tell the human story. On March 8, 1953, Lieutenant James Davidson brings his damaged Panther back to Antietam. Hydraulic failure, no flaps, landing speed 20 knots too fast. On a straight deck, he would have ditched in the ocean rather than risk a barrier crash at 145 knots. But Antietam has an angled deck. Davidson makes 4 approaches, misses the wires on every attempt. On the 4th try, he catches the 4-wire doing 142 knots, the fastest successful carrier landing recorded to that point. His aircraft stops with 11 feet of deck remaining. 6 months later, Davidson writes to Captain Campbell, "Sir, I never met you, but I'm alive to write this letter because you had an idea everyone said was impossible. My daughter was born last month. I got to be there because you refused to accept that good pilots should die for bad design. Thank you doesn't cover it, but thank you." The British implement angled decks on Ark Royal in 1955. The French convert Clemenceau. The Australians modify Melbourne. By 1957, every major aircraft carrier in the Western world either has an angled deck or is being retrofitted with one. The Soviets initially reject the concept. In 1959, after catastrophic landing accidents on their straight-deck carrier Varyag, they quietly implement it. Soviet naval records declassified in 1993 show landing accidents dropped 68% within 6 months. Captain John Moore flew combat missions over Vietnam from USS Coral Sea. He made 947 carrier landings between 1954 and 1973. He boltered 62 times. That's 62 potential barrier crashes, 62 chances to die or kill the sailors working forward. Instead, he just climbed away and tried again. Every pilot his age has a moment when they think about the friends who died in the 50s hitting barricades. They're alive because Dennis Campbell drew a line on a piece of paper and refused to shut up about it. Captain Dennis Campbell never gave a press interview about the angled deck. He was promoted to Rear Admiral in 1954. When HMS Ark Royal launched as the first carrier designed from the keel up with an angled deck, reporters asked him for comments. He directed them to Louis Boddington and the engineers at Farnborough. When the U.S. Navy invited him to the commissioning of USS Forrestal in 1955, the first American supercarrier equipped with an angled deck, Campbell sent his regrets. He was attending a funeral for a Royal Navy lieutenant killed in a training accident. Not a carrier accident, a helicopter crash, unrelated to anything Campbell had worked on. But the lieutenant had served under him in 1943, and Campbell believed you attended funerals for your people, always. In 1957, the Admiralty awarded him the CBE, Commander of the Order of the British Empire, for services to naval aviation. The citation was 2 sentences. Campbell kept it in a drawer. He retired in 1960 and took a position as a technical consultant for Hawker Siddeley Aviation, working on vertical takeoff jets. Colleagues remember him as obsessively focused on pilot safety, often irritating designers by adding redundancies to cockpit systems. Dennis would slow down every design review, recalled engineer Anthony Marsh, asking questions like what happens if this fails at night in bad weather. We'd tell him the odds of that failure were 1 in 10,000. He'd say, "What does the pilot do when it happens?" He never cared about odds. He cared about the one pilot who got unlucky. Campbell died on April 6, 2000, at age 92. His obituary in the Times was 4 paragraphs. The Guardian ran 6. Both mentioned the angled deck. Neither captured what it meant. Today, every aircraft carrier in the world uses an angled deck. American, British, French, Indian, Chinese, Russian carriers all feature the design. The U.S. Navy's newest Gerald R. Ford-class carriers have advanced electromagnetic catapults and arresting gear, but the deck is still angled 8 degrees to port. exactly as Campbell drew it in 1951. Modern carrier pilots make over 15,000 landings per year across the U.S. Navy's fleet alone. Bolter rate, approximately 8%. That's 1,200 missed wire approaches annually. Without the angled deck, those would be 1,200 potential barrier crashes. How many lives saved? Hundreds per year. Over 70 years, tens of thousands. In 2003, Lieutenant Colonel Arthur Black, U.S. Marine Corps retired, flew FA-18s off carriers from 1985 to 2007. He hunted down Campbell's family and sent them a letter. I never met your father, but I made 714 carrier landings during my career. I boltered 12 times, missed all the wires, and had to go around. On a straight deck, that's 12 times I might have died. Instead, I just climbed away and tried again. Your father gave me 12 second chances. He gave me a career. He gave me a life. On behalf of every carrier pilot who lived because of him, thank you. Dennis Campbell never responded to that letter. He'd been dead 3 years. But his son framed it because his father never kept his own awards, but he would have kept that. Some breakthroughs don't come from the experts. They come from the person who refuses to accept that's how we've always done it as an answer. Captain Campbell wasn't an engineer. He wasn't a test pilot. He was a bureaucrat who couldn't ignore dead friends, who had the audacity to draw a simple line on paper and ask why not. The angled deck saved more lives than any medal recipient. It revolutionized naval warfare more than nuclear power or guided missiles. But it didn't come from committees or laboratories. It came from a train ride, a notebook, a sketch, and the refusal to shut up when everyone said it was impossible. History doesn't always belong to the loudest voices or the highest ranks. Sometimes it belongs to the one person who won't let good people die for a bad design.